Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the Unit 3 group work. So let's see, this is on logarithms and exponential functions. Couple things that you really want to make sure that you understand. Make sure that you understand that a logarithm and an exponential function are the same type of function. They're just inverse operations of each other, or inverse functions of one another. So that you can convert between the two of them by just switching up the variables a little bit. So a common thing that we're going to reference back to over and over again is that you can switch between the two. So you want to memorize the formula that converts from exponent to log. For an exponent, if we have a base of a and a power of x, and if it equals some number y, I can rewrite this exact same expression as a logarithm like this. Log with a base of a, so the little number is called the base, and then of the number that we get after taking the exponent, y, is equal to the power, x. So it solves for the power of the exponent, basically. And you can use these two equations interchangeably to just change from exponent to log and log to exponent. And in fact, the first two problems, so these 6 little problems here, all have to deal with just this part of it, converting. Because converting is like a big part of understanding logs and exponents. Okay, so here we go. These are already written out as exponents, and I need to rewrite them as logarithms. So here's what I'm going to do. Each one of the variables represent a different part of it. So 2 is a, -3 is x, 1/8 is y. So I'm just going to rewrite this using those same letters like this as a log. So this becomes log with a base of a, so 2, and then of the solution value, so y, so that's going to be 1/8, and then equals the power x, which is -3. So now I'm just going to put parentheses around these this fraction just to show that it's like in this log function, and this is my answer converted to a log. Now I'm going to do the next one, same process. So log with a base of e of 12 is equal to the power x. Now, when I see log base e, that's another log property that I understand, and that's this, that whenever I see a log with a base of e of any number, doesn't matter what it is, it's the same exact thing as saying ln of x. In other words, the natural log of x. It's a special case when the base is e that it turns into a natural log like this. So I'm just going to rewrite this as ln of 12 is equal to x, because log base e just turns into natural log, okay? So the next one that I have is, again, just rewriting it as a log. Log with a base of 3, because that's the base on the exponent, of 5 is equal to x minus 1. And that's it. That's written as a logarithm. So that's converting from exponent to log. Now let's convert from log to exponent. So again, we just recognize what the variables are. 4 is a, 16 is y, 2 is x. So we just rewrite it in exponent form. So it becomes 4 to the power of 2 is equal to 16. And that's a lot more familiar to us, right? Because we know that 4 squared is equal to 16. This is the exact same expression, just rewritten to solve for the power. That's it. When I see log all by itself, it actually means log with a base of 10. Because whenever you see log all by itself, log of x or log of y, whatever, it secretly means that you have a log with a base of 10 on it. It's kind of just like an implied thing that you know. So I'm going to rewrite this with a log of a base of 10. So log with a base of 10 of 1,000 is equal to 3. So rewriting this as an exponent, it's 10 to the 3rd power is equal to 1,000. Natural log is really log with a base of e. So I'm going to rewrite this as log base e of x equals 3. And then convert this to an exponent. So it's e to the power of 3 is equal to x. And now these are all converted from log to exponent, and I'm done with number 2. For the next couple of problems, I'm not going to use my calculator at all, but I need to find actual values for each of them. We're going to use a bunch of log properties to solve for these. So if you have access to your notes, make sure that you bring up that list of log properties that we have. Let me zoom in a little bit too. Okay. So for number 3, we're converting to exponential form. Wait, evaluate each by converting to exponent. All right, so we need to turn it into an exponent and then evaluate it. So it just says log, and remember that when it just says log, it actually means that we have a log with a base of 10. So I'm just going to rewrite this then as log base 10 of 0.01. And let's say that it's equal to some value x. So if I were to rewrite this as an exponent, it would be 10 to the power of x is equal to 0.01. So my goal for all of these is once I turn it into an exponent, I'm trying to turn this number, this value that we have in our logarithms, into an exponent with a base with the same exact log base that we have. So since I have a log base of 10, I'm trying to turn this into an exponent with 10 to the somethingth power. So that's my goal ultimately. So let's see how this works out. Well, 0.01 is the same thing as saying 1 over 100. And 100 is the same thing as saying 10 squared. So this is the same as saying 1 over 10 squared. Since I have 10 squared here, if 10 squared is in the denominator, I can convert that into an exponent with a base 10, with a base of 10. And that's 10 to the negative second power, because if you were to go backwards, 10 to the negative second is rewritten as 1 over 10 squared. That's just a rule of negative exponents. So look again as like to what we've written. So we wrote at the very beginning, 10 to the power of x is equal to, and then at the end we get 10 to the negative second. So since they have the same bases, that means that the powers are the same. So that means that x is equal to -2. That's our answer. And we know you can just plug that into your calculator and get -2, but this is where you need to show all your work, right in here. So similarly, if I rewrite this as this equals x and then write it as an exponent, so 3 to the power of x is equal to 1 over 27, I can work through a very similar process of this, because 27 is the same as 3 to the third. And if 3 to the third is in the denominator, I can turn it to 3 to the negative third. And I see really quickly that x is just equal to -3. See, so that's like using the conversion rules to kind of get to a solution real easily by hand. All right, so set this equal to x, write it as an exponent, so same steps. But then 625, if you just keep dividing it by 5 over and over again, is the same exact thing as saying 5 to the 4th power. So 5 to the x is equal to 5 to the 4th, and that means that x is equal to 4. All right, so that's all of number 3. Now let's move on to number 4, and then I'll probably start up a new video for the expanding and condensing problems. Okay. So evaluate each using different logarithmic properties, and you must show your work. So for the show the work part, I'm just going to show you guys the property that we're going to be using. So this again just comes from your big list of log properties that you're supposed to know. This log property is that the log with a base of a to the x is equal to just x. So, if they have the same base and you have an exponent in your log, then if the bases are the same, then that means that it's just equal to the power. The reason that that's the case, why it works, is because if you use like the power rule for logarithms, you can move that exponent out to the front, and then log base a of a is just equal to 1. So this property here just tells you that this answer is just going to be equal to whatever the power is on the exponent, which is 3. So 3 is your answer, and this is the property that we used. Okay, if log base 7 of 1 is equal to some number, we'd use the property that log with any base, it doesn't matter what it is, let's call it a, if the number that's inside the log is 1, it's automatically going to be equal to 0. So even though the base is 7, as soon as I see that 1 there, I know for a fact that this is just equal to 0. So here is the property that I use to get to that answer. The last one, I'm going to use a couple properties. The first property that I'm going to use is that the natural log of something is equal to the log with a base of e of that number. So this is one property that I use. And I use it to then expand this to turn it into a log. So I have a log with a base of e of the square root of e. And then this isn't really a property, but the square root of anything is really equal to the 1/2 power of that number. So this is the same thing as saying log base e of e to the 1/2 power. And then we're just going to use the same exact property that we started with, log with a base of a or any number. And if I have that same number raised to a power of x, it equals x. So using this property with this logarithm here, so log of the base that's the same as the base of the exponent, and it's just equal to the power, so that means that this is just going to be equal to 1/2 overall. So these are the two properties that I used to get to this conclusion. All right, and then that's it for the majority of the log properties. We're going to use some more log properties here in a second for the condensing and expanding problems, and then a couple more of them for the lowest base formulas. All right, so that's it for this video.